Okay, so we have one problem left, and then as I said, we'll get into your homework assignment. We can go ahead and start working our way through there. There was only one problem left on our paper that I wanted to look at. Just a reminder, remember tomorrow is your exam. Look for it to have law of sines, law of cosines on there. You'll also have this material, graphing, sine and cosine, but it's more my giving you function and saying, okay, what's the amplitude? What's the period? What's the phase shift? Okay, and then there's one other thing, but I'll probably go ahead and take care of that when we get back from Thanksgiving. And I also did go ahead and put one problem on there, just like your happy minutes, where I gave you a radian measure. You'll go ahead and sketch it for me, reference angle, and then you'll go ahead and evaluate all 6 of the trig functions. Okay, so shouldn't be too bad. In fact, the first half of it is multiple choice. I like to do that on your tests, sometimes on the quizzes, and you can always do what? Retake it. Well, you can't always retake, that is true, but during the test you can always use your notes. Yes, so you have that advantage. All right, well, the only thing I started to bring up, and we kind of ran out of time yesterday, was this idea of a midline. So we have this line that always goes through the exact middle of every one of these graphs. It always starts on the x-axis, and the only thing that changes it is the vertical shift if you move up or down. So you'll notice, okay, if I started here at y equals 0, the x-axis, it shifts exactly what that vertical shift is telling me. And we always want to write that as an equation. Okay? So you could probably go ahead and get the midline taken care of before anything else. All right, well, let's take care of this last problem and we'll get to the homework. It says graph cosine of x minus 2. Now, what was a key indicator, like a tell, to let you know that's exactly right? See, Nathan already knew where I was going with this. How would I know that minus 2 is vertical rather than horizontal? We take the opposite. If we'd wanted this to be horizontal, it would have been placed in parentheses. If there's no parentheses, I have to believe that that's a vertical shift. So I'm just going to move everything down 2. So in fact, where would your midline be? It would be at negative 2. So I can already go ahead and just put him right here. I know it's y equals negative 2. And if there is no vertical shift, it stays right at y equals 0. Okay, that's just the midline. Okay, well, kind of walk me through this process here. I want to graph cosine of x minus 2. So let's start with the parent. Where does cosine begin? Always a maximum. So 1. Then we have 0, minimum, 0, and then a minimum, right? There you go. There you go. So then we have that curvy V. All right, looks just like this. Let me go ahead and put a few more points on here. What? Brandon, are we okay? Oh, that's how I roll. I don't know. I'm trying to be cool. My math is on fleek. Do we still say that? Really? Ah, well, it's a good thing math is my bae. Do y'all say that anymore? Huh?
Say your bang.
Bae. Really?
Yeah.
I'd make a joke, but it'd be pretty crappy. Anyways, okay. So this one, again, maybe we don't need to go ahead and do the whole process. Like on this one, you're just taking every one of these points and doing what with it? Yeah, you're just shifting it down too. So if you don't feel you need to go ahead and use the strategy I've been showing you, don't feel obligated to do so. This is just going to work every time. If you have one with multiple transformations, maybe it's not a bad idea. So let's walk through that strategy. The first thing I'm going to do is set up a compound inequality. Okay, I'm going to go ahead and say less than or equal to, less than or equal to. Now for sine and cosine, we always start with 0, end with 2 pi. Always, because 2 pi is the period for each of these graphs. It's how much is needed before they repeat, before they cycle again. So what am I going to put in the middle here? Now, would it be the x minus 2? Just the x. Remember, we talked about the fact that minus 2 is not in parentheses. So he has to be vertical. Well, you'll notice whenever we do this, we always want to solve for x, right? But what do you notice here? Yeah, there's nothing happening horizontally, so sometimes this will happen. So I'm done with him for the moment. I'm going to put him to the side. Now let's look at the critical values for cosine. We started with a 1, a maximum. Then we went 0, -1, 0, and a maximum, right? So that -2, he is a vertical transformation. So whatever you see is exactly what I'm going to do to these critical values. So I'm just going to take each of them and subtract 1. So 1 minus 2, -1. All right, so 0 minus 2 is -2, -1 minus 2. And then when you start getting to the repeating x's, you'll get repeating y's. So this should be a -2, and this will be a -1. Now remember, these y values that I just changed, that's half of what I'm looking for. Because remember, I'm looking to create ordered pairs, right? Is everybody okay with how I did that? Okay. Now I want to take those y's, and I want to go ahead and pair it up with the x's. That lower boundary, whatever he turns out to be, I'm always going to place him with the first critical value. Where am I going to put 2 pi? I'm always going to place him with the last critical value. And see, right there, I've already got 2 ordered pairs. The top row is the x's, the bottom rows are the y's. Okay. Now, how am I going to find the other 3 x values, though? Divide what by 4? There you go. Whatever the distance is between your upper and your lower, here it's 2 pi, we always, always, always divide by 4. Will we always divide by 4? Every time. Every time. So what is 2 pi over 4? Yeah, it's just 1/2 pi, right? So now I'm starting with the lower, and I'm just going to add it over and over. 0 plus pi over 2. Okay. Plus pi over 2. 1 pi. Plus pi over 2. 3 pi over 2. There you go. Okay. So see, I've given myself 5 ordered pairs. This will be 1 period on the graph. Well, take a look at what happens. The first ordered pair is 0, -1. So 0, -1. Then I have pi over 2, -2. So pi over 2, -2. Pi, -3. Then we have 3 pi over 2, -2. And we finish up with 2 pi, -1. Okay. Now remember, that's just 1 period. So I can repeat that pattern over. What would come next is a 0, then a minimum, then another 0, and I'm out of room. But take a look. It's the exact same graph, only what happened? Everything was shifted down too. What we would expect to happen. So see, whether you just go ahead and apply the transformation yourself, or you run through this little strategy with the ordered pairs, you're always going to get what you need. Okay, makes it real, real easy. And then, of course, when we shift vertically up or down, the midline just goes right with it. And that's it. That is graphing sine and cosine. Okay. So now what I want to go ahead and do, are there any questions on your assignment? What problems would you guys like to look at? Okay, well, let's do it. What you got? All of them? Don't know that we have time for all of them. One in each section? We could do that. Okay, so 1 through 4, what do you like? 2. 2 is the one I heard, but do 4? Okay. So let's say we have this. 7 cosine of 4x plus pi, and then -3. Okay. Well, remember, a is what you're going to multiply the trig function by. So that's whatever's out in front. B is always in front of x. That's your x coefficient. C is whatever you add or subtract to x. And then D, okay, D is your vertical shift. That's always what's outside. Typically, you'll find him at the end. Okay. So for numbers 1 through 4, it says determine the amplitude and the period. Okay. Well, the amplitude, remember, had the absolute value of A. Does anybody remember the period formula? 2 pi over, oh, we're close. 2 pi over B. Oh, I see what you're doing. You're actually telling me what to do. Yes. So the formula is 2 pi over B. There we go. Okay, well, the amplitude would be the absolute value of 7, because that's the value of A, right? Well, that would just give me what? 7. So that means 7 is half the height of my wave if I were to look at him. So he'd be 14 units tall in total. The amplitude is only half. Now, what Israel was telling me about for the period, 2 pi over B, well, but I see that B is 4, so 2 pi over 4, so that would just be pi over 2. Okay, so that's all you have to do on the first 4. In fact, that pretty much, as far as this section goes, is what the test is going to look like. I'll just go ahead and give you some kind of function, and I'll just have everything listed below. Find me the phase shift. Remember, the phase shift had a formula of C over B. Okay. You don't remember this? Oh, okay. Well, it's a good thing we're going over it. What's the value of C? Pi over, what was B? 4. So I know the entire graph is going to be shifted what direction pi over 4 units? Would it be to the right or would it be to the left? Okay, why to the left? It says plus. There you go. Remember, when you add or subtract, you take the opposite. Okay, so this would be pi over 4 left. And that's one thing you'll want to do. You'll want to go ahead and give me an arrow showing me the direction, or just actually write right or left. Okay. Let's see, what else can we find here? We got the period, we got the amplitude. Now, of course, these problems aren't asking for the phase shift. That's just if you wanted to go ahead and take a look at that. What would the midline be? Yeah, -3. But here's the thing on the midline, again, just like tomorrow, don't just go ahead and tell me, in this case, -3. Always write it as an equation, so it'll be y equals. And that's pretty much what your test is going to be like tomorrow for graphing sine and cosine. I'm not having you sketch one on the test. Okay? Because you'll be doing that on the homework. Okay, does that make sense? Okay. Well, what do we got for our next section? 5 through 8, use the transformations to graph each equation. Okay. So this is, just what we were doing. Which one would you like to look at together? Numbers, I heard 6, I heard 8. Okay. So let's see, how many people want 6? How many people want 8? Okay, so way more hands going up. All right, so we'll do 8. -3 sine of x plus 2. Okay. So let's go ahead and run through this process real fast. Would you like me to graph sine normally, or are you okay? Do you want me to graph the parent? Do? Okay. So sine always starts with a 0. Then we have a maximum. Then we have a 0. Then we have a minimum. And then we have another 0. Okay, the max and min are 1 and -1. Okay, and then I'm going to go back in the other direction. So it's probably going to look something like this. Oh, that was weird. Ooh. Okay, it's acting kooky. Yeah. So there's the original parent, their sine. Okay. Now, let's go ahead and start with our compound inequality. All right. Less than or equal to, bless you, less than or equal to. But our compound inequality for sine and cosine, we always put it between what? 0 and 2 pi every single time. So what's going in the middle here? Just x. That's the only thing in parentheses. There is nothing happening horizontally here. So, that's good news for us. There's nothing to take care of. We got the x, boom, we're done. Okay. Now let's go to the critical values. What are the critical values for sine? Okay. Now, is there anything that's changing them? Okay, so we are adding 2 and what? There you go. And it's just like your order of operations. We know those are vertical, so they have to apply to the critical values because they're outside the parentheses. So we're going to multiply first, and then we're going to add. So let's see, -3 times 0 plus 2. 2. -3 times 1 plus 2. Okay, is everybody okay with these? Okay, then 0 again should give me another 2. There you go. -3 times -1 plus 2 will give me 5. So these are the y values I need. Okay. All right. Remember, why did we do that? Well, just because. just because. Yeah. Okay. I got one for you. Andrea, you'll like this one. What do you call a sick insect?
What?
Secant. Secant.
Yeah, no, I get it.
Okay. All right, now how do I get my x values? Okay. Lower boundary with the first critical. Upper boundary, last critical. Now the distance from 0 to 2 pi is 2 pi. Always, always, always divide this distance by what? 4. So just like on the last example, it's going to be pi over 2. Now again, that just happens to be occurring for these random examples. It's not always going to be pi over 2 that you add. Just be careful about that. So this would give me pi over 2 plus pi over 2. Pi plus pi over 2. 3 pi over 2. And of course, 3 pi over 2 plus pi over 2 should get me to 2 pi. All right. And let's see here. We have the first ordered pair 0, 2. So I'm going to put him right there. Then we have pi over 2, -1. Okay. Then we're going to go pi to the right, 2 up. Then we're going to go 3 pi over 2, 5. And we're going to go ahead 2 pi 2. So 2 pi 2. And there we go. All right, so I'm just going to take that pattern and I'm going to repeat it over and over and over again. So it looks like my next one should be over here, right there. Then I'm going to go another 2 over, have one right here. Another 2 over, have one right here. Right here. And I should be able to fit in one more. There we go. Okay. There you go. There is -3 sine of x plus 2. Bless you. In fact, what's the equation of my midline? Y equals 2. Remember, that's just the vertical shift. Okay. What would the amplitude be? 3, the absolute value of A. Okay. What would his period be? Remember, this is 2 pi over B. What's the value of B? 1. So 2 pi over 1, the period would be 2 pi. Now, again, on these, you don't have to find that. This is just, again, kind of reinforcing that idea. Does anybody have any questions about that? Okay. All right. Next section. Looks like we have 9 through 12. Looks like, again, we're just going to go ahead and graph, but this time it is wanting those values. So what would you like? 9, 10, 11, or 12? 12? You guys agree? 12 and 10? Okay, so how many people want 10? How many people want 12? Okay, let's go with 12. All right, now there is one thing I'm going to do, because on these you'll notice they've already factored out the coefficient of theta. Now, the fact that they put theta in there changes nothing. If you want to change that back to an x, please feel free. So sometimes they may go ahead and put theta, but it's still the same process. Okay. So what you're doing here, just by looking at the function, if the coefficient of theta or x is 1, well, you can tell exactly what your period is, or show me what your phase shift is. So I know it's 1. But what direction would it go? Left or right? Left. Okay. Now, personally, for the phase shift, I prefer to go ahead and factor out that B coefficient. rather than use the formula. But if you want to use the formula, please feel free. Okay. Here's one thing I would tell you. I would go ahead and multiply the pi over 3 back through. So negative 3 cosine of pi over 3x plus pi over 3 minus 2. Especially if you're wanting to go ahead and list A, B, C, and D, okay, you'd want to make sure that B is multiplied through. Because if I pull out the pi over 3 like the problem is given to me, C is not 1. Okay, C is actually pi over 3. You just have to make sure it's multiplied through. Okay, well, I think the most important thing here is going to just be getting the graph. Okay, so let's go ahead and take a look at it. I'm going to say less than or equal to, less than or equal to. We always put these between what? 0, 2 pi. What's going in the middle? Pi over 3x plus pi over 3. Again, how do we know that? The parentheses, yes. Now, even though the pi over 3 is originally outside the parentheses, it's still inside the function. We just multiplied it back through. So I'm going to say pi over 3x plus pi over 3. There we go. Okay. So this one we actually have to do something. What is it? We could, you want to take care of that pi over 3 in front of x first? Or we could go ahead and subtract out the pi over 3. Typically, we go ahead and add or subtract first and then worry about the division. So let's do that. So whatever I do to the middle, I've got to do to each of the 3 sides. So minus pi over 3, minus pi over 3. So that's negative pi over 3, less than or equal to pi over 3x, less than or equal to, well, now I need 2 pi minus pi over 3. Let's see here. I'm going to put 2 pi over 1 minus pi over 3. Well, common denominator would be what? 3. So it looks like that would give me 6 pi over 3 minus pi over 3. That would give me 5 pi over 3. Okay, so Lily Bell, where'd I lose you? Everywhere. Okay. Well, let's start back at the beginning. We started with our compound inequality. Now, why did I put this in between 0 and 2 pi? It's in what? My parentheses. Whatever is in those parentheses, or even multiplied against the parentheses, that's everything horizontal. Okay. So all I did here was just go ahead and solve an inequality, just like I'm solving an equation. See, I first got rid of what I was adding, and then I got rid of what I was, well, now I'm about to get rid of what I'm multiplying. Okay? So the best way to get rid of pi over 3 is to multiply by 3 over pi, right? Because if you think about it, if you go ahead and put 3 over pi times pi over 3, those 3's cancel, those pi's cancel, there's your 1. And that's what we're wanting in the middle. We want 1x. But somebody help me out. What's going to happen here? What's 3 over pi times negative pi over 3? Negative 1. There we go. So negative 1 is less than or equal to, well, I just showed you those are going to cancel as well. There's your 1x, less than or equal to, now let's think here. 3 over pi times 5 pi over 3. That's just going to be 5. Because the 3's cancel, the pi's cancel, I'm just left with 5. Okay. And you'll notice what I'm providing you, this is the first time we've seen that pi dropped out. And that's perfectly fine, right? Okay. Because look at your grid. What do you not have horizontally? Yeah. I made sure that all the grids are going to work with that particular problem. So now this one is ready to go. This is going to help me create my x's. Okay. So now what do I use to create my y's? Okay. So I'm going to use those other transformations. Yeah, that negative 3 and the minus 2. But what am I applying those to? What are the critical values? For cosine, it's a maximum. Then we have a 0, then a minimum, 0, and then 1. So what am I going to do first? Subtract the 2 or multiply by 3 or negative 3? There you go. Always follow your order of operations. So for each of these 5, I'm now going to take care of the outside transformations. See, we've already taken care of the inside with the compound inequality. All right. So let's see. 1 times negative 3 minus 2. Now negative 1, because this will be negative 3 minus 2. So if they're both negative, there you go. Negative 3 times 0 and then minus 2. That's just negative 2. Negative 3 times negative 1 minus 2, that would be 1. And then these are going to repeat. 0 would give me negative 2. 1 would once again give me negative 5. Okay. What's outside the parentheses will affect your critical values. What's inside the parentheses will get you your x's. All right, so I'm going to remove these because I've transformed them. Now, even though we don't have pi, that doesn't change anything. Well, how do I pair these up? Okay, so negative 1 will go with negative 5. 5 will go with the second negative 5. And isn't it the same steps over and over again? Yeah, that's what's nice about this. Okay. So there, for negative 1 to 5, that's a distance of 6. And what do we always do? Divide by 4. Well, we always divide by 4. Always. Okay, so what is 6/4? 3/2. And if it helps, maybe something easy like this, if it's an exact decimal, maybe you can go ahead and do that. 1.5. What's negative 1 plus 1.5? Ooh, no, we're adding. So 1/2, so just 0.5. So what's 0.5 plus 1.5? 2. And then 2 plus 1.5 would be 3.5. Sorry, I didn't hear. And will 3.5 plus a 1.5 give me 5? Yeah. Now, I wouldn't do that with pi because pi isn't an exact decimal. Encourage you to work with the fractions on that one. But if it's something like this, yeah. Okay. And now we have my 5 points. Okay, Lilybell, are we still good? Okay. Anybody else confused? Anybody not sure where I got something from? So what's my first ordered pair? Okay. So from here, I'm going to go negative 1, negative 5. So I got a point right here. Then I'm going to go 1/2 and then down 2. Then 2, 1. Then I have 3.5, negative 2, so about midway. And then 5, negative 5. There we go. And now I just want to repeat the pattern. So after this minimum right here, what would I get? Oh, we're a little off. 6.5, negative 2 would be right here. And then I think the other one, we could probably just fit it on. It would be a maximum right there. And then over here, I'm going to go 1.5 to the left. Just completing the pattern. Okay. And this would be negative 3 cosine of pi over 3 times theta plus 1 minus 2. So that is probably the biggest one you'll have on this paper, I believe. Okay. What would you say the amplitude is? Yeah, remember it's the absolute value of A. So the amplitude would be 3. The period is 2 pi over B. Well, what's the value of B here? Pi over 3. Now remember, whether it's x or theta, it's always that coefficient. So I'm going to put 2 pi over pi over 3. Well, what do we do if we divide by a fraction? We take the reciprocal. So this would be 2 pi times 3 over pi. And what do you notice? Those pi's cancel, so 2 times 3 is 6. And you'll notice, how far is it from negative 1 to 5? That's 6. That's what my period is. It takes that long before it's going to repeat again. Okay. The midline. What? Oh, yeah, if you feel confident, yeah. I mean, you don't have to graph it tomorrow, so you won't necessarily be doing this unless you just want to because it's super fun. You know, maybe next week when you're going to sit down for your dinner with your family, what are you thankful for? Pre-calculus. One person laughed at that. Okay. Well, okay. I guess if you want to. If you want to, yes. I'm thankful for all of you. Well, actually, I am, because without you, I wouldn't have a job. So. No, but I am thankful for you. I like coming in every day and seeing you guys. I look forward to this class. I hope you do the same. You don't dread coming to this class. I don't know, man. I don't know. All right, 12:31. All right. Here we go. So let's go ahead and get one more. And I'll tell you what, we should actually have time tomorrow because I don't believe it'll take the entire time to go ahead and take your test. So I'll go ahead and put up the key tomorrow, maybe in the last 7 minutes or so. But here, what do you want to do for 13 to 16? You could do that. You could just put it in the calculator, yeah. Okay. Let's try this one right here. 2 cosine of pi over 2x. So I'm looking for a cosine graph that's been what? Okay. The maximum is now what? See, because what's your amplitude? The amplitude is 2, so it should actually be 4 units tall. All right. And then what's the pi over 2 going to do to it? Would I expect a skinnier or a wider graph? Why wider? It says 1/2. Remember the reciprocal. So I'm looking for a cosine function that's twice as tall as he was and double his normal length. Okay. Alize is saying B?
Yeah.
All right, so if the period is normally 2 pi, and I'm going to double it because of the reciprocal, then it should be 4 pi. So does it take 4 for that graph to repeat? Yes. That is absolutely right. So I would say that 13 is B. Yeah. Or like, Genevieve said, you could just plug it in the calculator and see what matches up. Or you could just kind of think through your transformations. What does a negative do? It reflects it. Okay. There you go. And then I think you got a couple of, whoops, let me take that off because you probably don't need to see that. Okay. But then here you're just doing the opposite. Write a equation that would match the graph. And then we'll just go from there. Okay. But I don't have you do anything like that on the test. All right. So are we feeling a little better about sine and cosine? About graphing it? Okay. Good. Good. All right. Thank you.